Hello viewers, in this video we are going to look at sterilization kinetics. So in a fermentation reaction, if the medium or reactor or some sort of equipment involved in a fermentation reactor is being contaminated, then the contaminating organism might interfere with the desired product formation, or it can affect in various ways. So in a fermentation reactor or reaction, everything needs to be sterilized, whether it is the equipment, the medium that is used, have to be completely sterilized, have to be completely free from microorganisms or any growth. So when you say sterilization, it is destruction of all living forms. No matter what the living forms are, it needs to be completely sterilized. So say aerobic fermentation reaction, we need to inject air or need to give air for the microbial growth. That needs to be sterilized. So this sterilization can be done with the help of heat, with the help of chemicals, with the help of irradiation, and also filtration, or a combination of many of these. So with the kind of medium or the kind of equipment we use, we have to prefer what type of sterilization suits the component more. You have to go with it. So in this video, what we will have looking at more on the kinetic aspect of it. So in this thing, we look at the thermal kinetics. So thermal kinetics. So microorganisms can be sterilized with the help of heat. Heat sterilization can be moist heat or dry heat. We're also going to see these things in detail now. So sterilization. So for any organisms, sterilization heat. So at a particular temperature, their viability decreases. So after it attains a particular temperature, the organism begins to lose its viability, and it begins to lose its structure, and thereby cannot survive at that particular heat. It can differ for different types of organisms. So when you take microbial sterilization kinetics, it follows first order reaction. So it can be written as minus dN by dt is equal to Kd N0 minus N dash, which is equal to Kdn. So you can see Kd as specific that constant. So N0 initial amount of organisms present. So N dash organism present after time t. So the N refers to this surviving organism. So this specific dead constant depends on microbial type and the temperature used. So integrating this at n is equal to n0 at time t is equal to 0, at time t n is equal to n. So we get ln n0 by n is equal to minus k dt is equal to, we remove the natural logarithm, and you get n is equal to m0 e power minus k dt. And this particular thing and is a function of temperature. So as the temperature increases, it increases drastically. So it can be made with the help of Arrhenius equation. From the Arrhenius equation, so the rate constant Kd and temperature can be related as Kd is equal to A e power minus E by RT. So in this, A is the empirical formula. E refers to the activation energy in calories per mole. Empirical. So all gas constant expresses 1.98 calories per Kelvin per mole, and T absolute temperature. So when you plot a graph, time versus n0, you get a graph like this. When you plot a graph t nt minus by n0, you'll get a similar graph like this. So we plot time t with the natural logarithm of n, and ln of nt by n0, we get a straight line where slope is equal to minus k. So this is how we get it. So we can also say a term called decimal reduction time. So it is the time at which 10% of the original population remains viable at a given temperature. So it can be written as this can be written as Kd. So the survival curve is time n0 we get a slope minus k. This is what we call as survival curve. So in this, so when you take spores, the Kd value of spores is less than for vegetative cell. This is because Kd, the spores are highly resistant as compared to vegetative cells, and they can resist thermal sterilization to some extent. So now you can see that. So when we take an organism like Bacillus stereothermophilus, its Kd value is 0.77. So the decimal reduction time, D value becomes 3 minutes. So this says that a log reduction of Bacillus stereothermophilus occurs for every 3 minutes at the temperature, is the whole temperature of 121 degrees centigrade. So this is about sterilization kinetics. Meet you in the next video. Thank you.